Alright, in this recording, we're going to look at atoms and molecules as our first foray into a review or a crash course in basic chemistry. So as we look at our outline of this course, we look at the hierarchy of biology. And at the top of this hierarchy is the most inclusive categorization of the ecosystem. And we work our way all the way down. We're going to start with the quarter with atoms and molecules, the smallest parts of those things that make up living stuff. And what we're going to see throughout our study of biology are what are called emergent properties. So this idea of an emergent property is that I can take the parts of a system, and if I organize them in a specific way, I get new properties from them, more than the sum of their parts. And so what this brings to light is two ways of doing science, two ways of looking at the world. One is a reductionist approach, and this is the idea that I'm going to break things down into their pieces and study the pieces to understand how that thing works. And in contrast to that, we talk about a systems approach, when instead of breaking things down, I pull back and look at the big picture and see specifically what emergent properties are present, what comes from the organization of the system itself, more than the sum of just the individual pieces. So we'll look at examples of this. Sodium and chloride ions, two different elements, which we'll talk about in a minute, two types of matter. When you put them together in a crystal, you get table salt. And that table salt has properties that are nothing like any of the properties of sodium and chloride alone. So what we can do is then talk about this as life itself as an emergent property. So when I take the components of a cell, which we're going to study, we're going to break it down and study them, each in turn. When I organize them into a cell, I get this thing called life. And we'll talk about what that means a little bit more as we go along. But if we're going to talk about cells, I want to give you, or talk about atoms and chemistry, I want to give you some context, right? So here you can see a zebra. This is something that you're familiar with. And we know that zebras are made up of organs, like we are, mammals. And those organs are made up of tissues, and those tissues are made up of cells. So individual units that we'll talk about more, literally individual bags of biochemistry. And as we delve into cellular anatomy, we'll learn more about organelles. But all these pieces then are made up of molecules, and those molecules are made up of atoms. So atoms are going to be our fundamental unit of matter. Now, as we're talking about cells, I want to plant a seed here that we're going to talk about in greater detail later. The idea that there's two major types of cells out there, both prokaryotic, which are smaller and simpler, what we think of as bacteria, and eukaryotic cells, which are larger and more complex. So you can see here that big circular cell in the middle, that is a eukaryotic cell, and the little purple dots are prokaryotic cells. Every cell, though, is basically a bag, a greasy bag of lipids, in which is biochemistry that constitutes life. So when we look at an individual cell, we can see that it has this border, this membrane, that delineates it from its environment. That membrane, that cell membrane, is made up of molecules called lipids. And we'll talk about these in greater detail later. But again, I want to plant the seed and build context as we dive down deeper and deeper to get smaller and smaller, so you understand what we're talking about when we say atoms. But you can see here this cartoon, as I zoom in on that kind of purple membrane, I can see now on the right these little cartoon diagrams of like a circle with two little tails off of it. Each of those represent an individual phospholipid, special kind of molecule that makes up cell membranes. But what you can see here when we show it here is that that phospholipid itself as a molecule is made up of smaller, these balls here, the space-filling model. Each one of those balls that are kind of glommed together, each ball is an atom. And that atom is the fundamental unit of matter. It is the smallest piece of matter that has the properties of that type of matter. Now, to understand the different kinds of atoms, the different elements, we actually have to dive one more level deeper into the interior of the atom itself. And you may say, wow, I thought I was taking biology. What's up with all this chemistry? Biology is based on chemistry. And we need to understand the rules of chemistry, which are based on the rules of physics, to understand how biology works. So when we look into the atom, we see that every atom has a nucleus. And I don't want you to confuse this use of nucleus with the use that we'll use later when we talk about a cell's nucleus. This is very specific. The atomic nucleus is made up of two subatomic particles called protons and neutrons. All right? In this case, the neutrons are gray and the protons are red. Now, orbiting the nucleus are called electrons. These are three fundamental subatomic particles that we need to understand enough chemistry so that we can understand the biochemistry that is life. So, what we want to remember is that protons are positively charged, neutrons are neutrally charged, and electrons are negatively charged. All right? And the number of protons in the nucleus of an atom will dictate what kind of atom it is, what element it is. So you can see here on the left, you have an atom with 2 protons in the nucleus. That's a helium atom, and it has all the properties of helium. The atom on the right is a carbon atom. It has 6 protons in its nucleus, and it has all the properties of carbon. Now, when you consider the different kinds of elements out there, the different kinds of atoms out there, we call the different types of matter, different types of atoms, elements. So you can think of it like flavors. And if you were to walk into like Baskin-Robbins or an ice cream store and you see a list of all the different flavors of ice cream, this would be the different flavors of matter, the periodic table of elements. So just like if I order an ice cream cone with a scoop of chocolate on it, think about that scoop of chocolate being a single atom. That chocolate atom is the element chocolate, right? So it has all the flavors of chocolate to it, but I could take another atom, say of strawberry, and put it on top. Now, it's still a scoop of ice cream, it still is ice cream, but it has different properties. It's strawberry instead of chocolate. So when we look at matter, helium, hydrogen, beryllium, silicon, nitrogen, oxygen, phosphorus, silicon, carbon, boron, all these things are atoms, types of matter, with different flavors. And as we combine the different flavors, we get different sundaes. We get different molecules. And those molecules behave differently because they're made up of different flavors. Just like a sundae made of just chocolate scoops is different than a sundae made up of several different kinds of ice cream. I use lots of food analogies. I like ice cream. So, to look at that again, to take that to the next step, we know that the number of protons in an atom will dictate what type of atom it is, what element it is. Now, an atom in its natural state will always have the same number of protons as it does electrons. That balances, because remember, electrons have a negative charge and protons have a positive charge. And the number of electrons that are orbiting the nucleus will dictate how that atom, that element, interacts with other elements, and we'll talk about that as we talk about bonding. But what about those neutrons? I want to take one moment now to talk about neutrons, because sometimes the number of neutrons will differ within the same element, and we call those isotopes. So here, again, remember that the proton dictates what type of element it is. These 3 atoms all have 1 proton, hence they're all hydrogen. Now, in some cases, that 1 proton in the nucleus may be accompanied by a neutron, and that's called an isotope of hydrogen, and that specifically has a name called deuterium. If it has 2 neutrons with it, it's tritium. Why do you care about this? Because it affects how we do things in science, specifically nuclear medicine. So nuclear medicine uses isotopes. This is one way that we visualize lots of things inside the human body. So say we're going to inject you with this short-acting isotope. What are they injecting you with? They're injecting you with a different version of elements that have more neutrons. Isotopes can be radioactive. When I load up that nucleus with more neutrons, it can become unstable. And as it breaks apart, it gives off energy, and that's radioactivity. All right, so I want you to understand what isotopes are. That radioactivity is one method for us to do carbon dating. Right, so we talk about carbon-14 dating That's where you're going in and measuring the ratios of the different types of isotopes in a sample. And that's something that we can learn about more if you choose to learn deeper into that topic. But I'm not going to hold you accountable for it now. Do you know what isotopes are? Now, we can look at the flavors that are most associated with living things. We look at the different elements most associated, in this case, with the human body. And you'll notice oxygen, carbon, hydrogen, and nitrogen are top 4. And in fact, those top 4 are the vast majority of the elements that make up the human body, and that's most living matter. Right? So about 96% of all living stuff is made up of hydrogen, oxygen, nitrogen, and carbon. And I like to think of that as honk. Because what we're going to see is that when we start to combine different types of matter, different elements, that is chemistry, we're going to see that hydrogen wants to form 1 bond, oxygen wants to form 2, nitrogen wants to form 3, and carbon wants to form 4. So honk is a great way to remember 1, 2, 3, 4 for the number of bonds they want to form. So what is bonding? What is chemistry? We'll save that for our next recording.